in chapter 2, and today we're going to talk about now angle relationships. So last time we talked about segment relationships, and today I want to talk about angle relationships. The first thing about angles, remember we learned about the degree measures. And with the degree measure, our first postulate is called the protractor postulate, and it basically describes how to measure angles using the protractor, okay? Remember that on both sides it starts at 0 and goes to 180 left to right, but it also starts at 0 on the right hand side and goes all the way around to 180, okay? So if I were to find the measure of angle CBD, here's the angle that I'm talking about right here, okay? So starting at D, it's already at 0 if I look at my bottom number. Since it's at 0 on the right hand side, I'm going to stay with my bottom numbers, and when I come around to C, notice it hits it right at about 34 degrees. So we'll say 34 degrees. So that's how you would read it. If you were starting on, like for instance, ABC, for instance, since A starts at 0 and it's now the top number, when you read around, remember you're going to look at your top numbers now. Okay? So you'll always start at 0. Okay, the next thing that we're going to talk about is the angle addition postulate. And like I mentioned before, we talked about this. It's very similar to the segment addition postulate that we talked about last class in 2.7. The angle addition postulate, and sometimes you'll see me write it abbreviated as angle addition postulate. And remember, it's still the part plus part equals whole, okay? So angle ABD plus the measure of angle DBC is equal to the whole thing, which is angle ABC. All right? If we look at our first example over here, it says the measure of angle VUT is 17, let's see here. The measure of angle VUT, this whole thing right here, okay, is 175 degrees. So if I'm going to find the value of x, remember if I do part plus part equals whole, it's going to be our first angle, which is VUJ, plus our second angle, which is JUT, is equal to the whole thing, which is angle VUT. So when I plug in, I have 17x minus 3 plus 17x plus 8 is equal to 175. So remember, 17 plus 17 is going to give us 34. So we have 34x, negative 3 plus 8 is going to give us a positive 5, is equal to 175. When we subtract 5, we get 170. And when I divide by 34, I get x is equal to 5. Okay? Again, that's showing how you would do a problem with part plus part equals whole. Okay, the next thing is talking about our theorems. And these are a review of things that we've learned in postulates we've learned before. But since these are theorems, they're actually proved that they are actually correct and that they are a valid postulate. So the measure of angle 1 plus the measure of angle 2 is equal to 180. Any two linear pair angles are going to be supplementary. Complementary angles, any two angles that form a right angle are going to be 90 degrees because your right angle is a 90-degree angle. Okay? So let's go ahead and move on to the reflexive, symmetric, and transitive properties. Again, we've been talking about this for the last few classes, okay? Now they're going to apply to the angles. So the reflexive property of congruency would be angle 1 is congruent to angle 1. Symmetric would be angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. Remember, the symmetric property is like the switch, okay? And then last, the transitive property, if angle 1 is congruent to angle 2 and 2 is congruent to 3, then we cut out the middleman right here and just say the first and the last, okay? The bottom part right here is proving the symmetric property. So that's just giving it more example and showing you the proof of why the symmetric property is correct and why it's valid. All right, if I go ahead and move on over to the next page here, next slide. For congruency supplement theorem, what this one says is that if two angles are both supplementary to the same angle, then they are congruent. So if 1 and 2 are supplementary, and 2 and 3 are supplementary, then angle 1 has to be the same measure as angle 3. So for instance, if angle 2 is 30 degrees, and then angle 1 is 150, you know that they have to be equal to 180. Likewise for 2 and 3. If 2 is already 30 and 2 and 3 are supplementary together, then 3 has got to be what's left of the 30 degrees. So it would have to be 150 degrees. Okay? Complementary thing, congruency theorem is the same thing. If 4 and 5 are complementary, which means they equal 90 degrees. Okay? So suppose that 5 is 60 degrees and angle 4 is 30 degrees. Well, if 5 and 6 are also complementary, then 6 has got to also be 30 degrees as well. So these two would actually be congruent. Okay? So here's a problem using those two theorems. The first one says that angle 9 and angle 10 are complementary. So you know that they form a right angle. Angle 7 and angle 9 are congruent. Okay? The measure of angle 8 is 41 degrees. They want me to find the measure of all the numbered angles, okay? So 7 and 8 are actually going to be complementary as well. How do I know that? Because all 4 of these actually form a right angle, a straight line. If 9 and 10 are 90, then obviously these two also are going to be 90 degrees. So I can say the measure of angle 7 plus the measure of angle 8 is going to be equal to 90. If the measure of angle 8 is 41 degrees, then obviously when I subtract that from 90, that's going to give me 49. So the measure of angle 7 is going to be 49 degrees, okay? You already know that the measure of angle 8 is 41 degrees. Just like what we said a minute ago, whatever 7 is, 9 is going to be the same thing. So the measure of angle 9 is also going to be 49 degrees, okay? So if 9 is 49 degrees, then do you agree that measure of angle 10 is also going to be 41? Because again, these are complementary. So the measure of angle 10 is also going to be 41 degrees. It's going to be the same as angle 8, all right? Okay, let's go ahead and move on. Down here is now talking about vertical angles. And again, we mentioned vertical angles before, and we talked about them being congruent. Here's the theorem proving that vertical angles, angle 1 and angle 3, are going to be congruent, and whatever the measure is of 4, that 2 is going to be the same thing. Okay? So if I go ahead and do one of those problems, if we look over here, if I'm looking to find the measure of angle 2 and angle 3, I know that they are vertical, so they must be congruent. The measure of angle 2 is 4x minus 26, and the measure of angle 3 is going to be 3x plus 4. So, because I know that they are congruent, I know that the measure of angle 2 equals the measure of angle 3. So 4x minus 26 is equal to 3x plus 4. So, if I'm solving 3x minus 3x, I get x minus 26 is equal to 4, plus 26 plus 26, x is equal to 30. Alright, so if I'm finding the number of angles, the measure of angle 2 and the measure of angle 3 are going to be the same, right? So it doesn't really matter which one I plug it into. So here if I have 4 times 30 minus 26, that's going to give me 120 minus 26 would give us 94, am I right? Yes. So the measure of angle 2 is equal to 94, and then so is the measure of angle 3 because they are congruent. All right? So there's our vertical angles. The last thing is just going to talk about what we know about right angles, okay? Perpendicular lines intersect to form right angles. So if these two lines are perpendicular, then we know that there's 4 right angles all the way around, okay? All right angles are congruent, so yes, they are all 90 degrees. Perpendicular lines form congruent adjacent angles. So yes, 2 and 4 are congruent, 4 and 3 are congruent, 3 and 1 are congruent, and 1 and 2 are also congruent. And then the next one says that if 2 angles are congruent and supplementary, then each angle is a right angle. So that is also true as well. Okay, so 5 and 6, if they are congruent and supplementary, then they are each a right angle. If they are supplementary, then they must equal to 180 degrees. And if they both equal 180 degrees and they're congruent, then 180 divided by 2 is going to give us 90. So that's why both of them are right angles. And the last one says that if two congruent angles form a linear pair, then they are right angles. So notice again, same thing is very similar here. If they form a right angle, a linear pair, then they're supplementary. They're equal to 180 degrees. If they are both congruent, then they have to be right angles because again, 180 divided by 2 is 90.